Okay. I am still grading your tests, but I really think that I'll have them all graded and even in Power School by one. I'm not putting a lot of comments down, but it's really more, I just want to get them graded. You guys can then use the scoring guides to get feedback on like what you did right or wrong on your essay questions. Um, so I'll have those in the grade book. And if anyone needs to talk retesting, then why don't we do it very quickly why it's more fresh and not wait till like after Christmas. So that's why I'm trying to get them graded quickly and in the grade book. So drop by this afternoon if you guys want to talk about retesting anything with Unit 3 if you're not happy with your grade on the test. Okay. And then again, for those of you that just popped in, I'm going to use 3 colored pencils today. So I'm going to use a red and a yellow and a green. So if you can get something kind of the equivalent to that, or even like a marker, because we're only going to like shade in some stuff with them. So you're going to be writing with a pencil, not a pen, a pencil most of the day today. And ultimately, this is what we are creating. So when I say write small, I cannot stress that enough. Like I even run out of room, and this is a big 11 by 17-inch paper here. Okay. So, but I'm going to do it all on a smaller piece of paper because I know a lot of you just have smaller pieces of paper, and then you're going to kind of see how small I have to write and so on. Okay. You also are going to need worksheet 4.2 because after we draw some of these diagrams, I'm going to show you different ways that they can show these diagrams. So you then will have to, we're going to do some practice on 4.2 as well. Okay. So paper, colored pencils, and honestly, be glad that you're here today because this is going to make respiration a lot easier. I can never make it easy. This is like 32 steps, guys. I can't ever make respiration easy. No teacher can, but I can make it easier than you trying to like figure all this stuff out on your own, right? So drawing these diagrams will help tremendously. All right. So in Power School, in Google Classroom, I put just the assignment for today. I said, hey, I just need you to have like the first 3 lectures watched before January 4th. So I'm going through actually lecture 2 right now. And the reason why I didn't have you guys watch lecture 2 yet is because usually I have students watch lecture 2 and then we do the diagram in class. But it's almost like they come in and their eyes are like this big and they're like, Miss Spencer, I learned like I got nothing. Like that lecture, like it was all so far over my head. And I'm like, okay, well, once we draw the posters, you're going to feel a lot better about it. So I kind of want to do it backwards this year and see if it works better. We're going to draw out very simple parts of respiration. And then when you go and you watch lecture 2, it's going to like glue everything together and solidify it a lot more instead of going through it one time and it all just is going to sound like a foreign language. It's not going to sound like a foreign language after we draw some parts. Okay. All right. So the focus is cellular respiration, and you know cellular respiration is making ATP, right? And really the only thing that you guys probably know right now about respiration, and this is why this unit is so difficult, is that you guys probably know the equations, right? So let's go ahead and write the equation for respiration. We need oxygen, and write as small as you can, to be honest. I have to write bigger because I need you guys to be able to see it. And then I'm going to put C6H12O6 because I really am focusing more on the atoms here because we're going to break down glucose. So I'm going to bust apart these 24 atoms. I'm going to take them apart, take them off glucose till glucose is gone. And when I'm done, I'm still going to have those atoms, but these 6 carbon atoms are going to be here on 6 CO2 molecules. And all of these H's, they're going to be gone off of glucose, but they will now be as water molecules. So this, like I've kind of mentioned, I said this is a tough unit, right? It's kind of funny to like when you balance this, it's 666. It's like symbolic. So it's going to take 6 oxygens. We're going to get we have 1 glucose molecule. And when we're done, we'll have 6. So here's what I mean by the 666. And then there's 6 waters. Okay. But does this make sense over here? If I have 6 waters, don't I have 12 hydrogens? Here they are. Okay. And over here, if I have 6 CO2s, I have 6 carbons, right? How many carbons did we have in glucose? 6. Okay. So this is all kind of basic stuff that you need to kind of realize, because sometimes they'll ask really simple questions and you guys miss it. And I'm like, so you might think I'm making a big deal out of nothing, but if I ask you, where did the 6 CO2s come from? You need to be able to tell me there's 6 carbon atoms. So that's where the 6 carbon atoms and the 6 CO2, that's where those carbon atoms come from glucose. Okay. All right. Now I'm going to start with, speaking of glucose comes for animals via the blood, because you have to eat it. So I'm putting the bloodstream here. Okay. I'm going to go ahead and draw a red blood cell, even though we're not going to talk about that much yet. And remember, red blood cells, I'm putting O2 in there for oxygen. Okay, in my red blood cell. Because I mentioned, hey, we're going to need some oxygen. And I'm going to show glucose being delivered, because from your intestines, the glucose gets brought into your blood and your blood carries it to your cells. Okay, so our glucose is going to be delivered to our cell here. Okay. Now, speaking of cell, I'm going to move this back up, and I won't do this all block, I promise, but I want you to see almost my entire picture here. Okay. I need you to leave probably like 1.5 inches up here, but I'm going to draw a cell. And honestly, I need it to take up as much space as you can on that piece of paper. Okay. So let's just kind of indicate, okay, this is a cell. Let's just make it simple. Let's just make it, this is a little skin cell. Okay. And skin cells get glucose brought by the bloodstream. So there's I just wrote skin cell right there. So you know that we're looking at a cell here, because eventually it kind of doesn't really look very cell-like when we're done, because I'm about ready to put a ginormous mitochondria in here, because I need it super big, because we have to draw. I mean, look at all this stuff that I have to put and all that. I got to fit all that in a mitochondria. Okay. So I'm going to make a super big mitochondria that takes up probably half the cell. Okay. And we know that the mitochondria has 2 membranes, and we know why. And we know the inner membrane is folded. Just don't fold it too much, because I have to write a lot of stuff inside that space in the middle. So I'm trying to make this really big right here. I am going to put quite a bit of stuff like in here. Okay. So, but I have to put a lot of stuff in the matrix of the mitochondria. So I'm trying to make it really big. Okay. Hopefully, and it looks a little odd because usually the mitochondria are much smaller. Like a mitochondria would be more like that size. Like this might be more like a mitochondria, but we have to make it big. But let's go ahead and indicate where we're at here. So this would be cytoplasm. And then let's just make sure that you know, hey, this is a mitochondria. Okay. So this is what is super frustrating as an AP teacher. I teach you guys about respiration, right? And when we're done, if I say, describe the process of respiration, you're like, oh, okay, yeah, we just had 3 lectures on it. So I'm going to talk about what I learned in those 3 lectures. But this is what happens on an AP test. They don't say describe respiration. They call it something different. They say describe the catabolism of glucose. Or they say describe the oxidation of glucose. And that's the same thing. It's respiration. So we can say, like, I can call this respiration is what we're going to draw. I can call it respiration. I can call this the oxidation of glucose, because that's what's happening in respiration. I can call it the oxidation of glucose. Okay. Can anyone remember why I showed you guys a video of cats breaking something?
Catabolic
Very
reaction.
Good. And I was trying to help you remember cats break. So the breaking down of a molecule is a catabolic event. So we're going to break down glucose. So I can also call respiration catabolism of glucose. So if a question says, describe the catabolism of glucose, or it's talking about that, it's respiration. It's making ATP. And I don't know how they're going to word it on the test because it changes all the time. So I have to make sure you guys are familiar with everything. Because I sure hate for you to know every bit of respiration just because they called it something different. You don't even know like how to answer the question when you actually did. Okay. All right. Let's start with the first step. And there's 4 main parts to what's called aerobic respiration or cellular respiration. Okay. The first process is going to happen in the cytoplasm. We're not even going to get to the mitochondria for a while. We're going to make some ATP in the cytoplasm. Didn't know that, did you? You always thought the mitochondria makes ATP? There's actually a series of reactions that can happen in the cytoplasm, and the cell can make a little bit of ATP even without the mitochondria, right? Which makes sense because bacteria cells don't have mitochondria, but they can still make ATP, and they can use this first process, which is called glycolysis, okay? So let me go ahead and draw my glucose coming into the cell because it starts with glucose. And I'm just going to then be scientifically accurate here. I'm going to draw some transport protein there, some GLUT transport proteins, and let's get that glucose in the cell. Now, glucose looks like this. We're not going to draw it like this. It took me 15 minutes to build it. Can you imagine if I said, hey, diagram glucose, draw the 6 carbons, the 6 oxygens, and the 12 hydrogens, right? We don't diagram glucose like this because this is too messy. This is often how they will diagram glucose. They will just draw the 6 carbon atoms, and that's it. They won't show the H's and they won't show the oxygens. They will just diagram glucose as a 6 carbon sugar. So that molecule is glucose. Holy cow, I'm getting a blister from doing, this is the 3rd poster. Look at that. Workers' comp right there. Like, good Lord, this hurts. It does, respiration hurts. Okay, so we have glucose. And remember I said catabolism of glucose? Let me show you what that looks like. Catabolism or the breakdown of glucose. This is what we do. You just break off atoms. And pretty soon, all my glucose, all the atoms of it are going to be pulled off, and I don't have glucose anymore, okay? So this is all that's going to happen in these processes is we are slowly, step by step, going to remove this atom, and then we remove this atom, and then remove this atom until the glucose isn't there anymore. The atoms are, they're just somewhere else, okay? They're water. They're now in CO2, okay? So to start this process of breaking down glucose, let's think about this. Do you guys have sugar in your cabinet right now, and that sugar was there 2 months ago? Do you think that you have sugar that's probably 2 months old in your cabinets? Has it decomposed? Or is it still fine? Okay, sugar doesn't just break down on its own. It's a very stable molecule. So if we want to start to break down this molecule, then we actually have to add a little bit of energy to start the breakdown of glucose. So this very first step of taking glucose and starting to break it down costs the cell 2 ATP. Well, this is not starting out very good, right? We're trying to make ATP, but we're already down 2 in the cell, okay? Now, I'm really glad that I mixed up the order of things, and I teach you guys about signal transduction pathways, and you guys have made that flip grid because this is going to make a lot more sense to you. How do we use ATP for energy? Remember how we pull off a phosphate and just stick it on another molecule? Okay. And that changes the shape of the molecule. So if you think about it, I'm going to pull off, there's two phosphates because I have two ATP, and I'm going to stick those phosphates on the glucose. So now the glucose looks like this. It's got a phosphate over here. Okay, now I'm going to zoom in because I've got to get pretty close here. All this is going to go in the cytoplasm. So write small. So maybe you can see what I diagram and be like, okay, I can even put those closer together or whatever. Okay. So all I've done is I still have glucose. I just added two phosphate groups to it. And those phosphate groups came from ATP. Now, do I have ATP anymore? No. Does it make sense? Now I have two ADP in the cytoplasm. Does all that make sense? Okay. And after doing the signal transition pathways, this usually makes more sense to students. Okay. All right. This reaction, it took energy for this to happen. Okay. Also, I need you to know that every step, every time we change ATP, there is an enzyme that does that. None of these reactions happen on their own. Someday, when you're learning about respiration in your college class, your professors might have you memorize like all 32 enzymes. Okay. It's not fun. Like the enzyme that actually does this step is called hexokinase. You guys don't have to have those memorized for our class, but I need you to know that enzymes have to make all of these take place. Okay. So let's see if this kind of makes sense to you, because this was a picture off of a multiple choice AP Bio test question. Does this make sense? We have glucose. ATP is getting used. In this one, it's only showing you one, right? Do you see where the phosphate went? There was no phosphate. Now there's phosphate. Hopefully that makes sense. And do you see right there? They put a name there. That's the enzyme that does it because it ends in ACE. So I could ask you a simple question like this. What are the monomers of hexokinase? It's not even about ATP, but you need to know, oh, that's an enzyme. So that's an enzyme. It's made of amino acids. Okay. All right. Which kind of also relates to what I'm going to show you here is kind of lecture 1 stuff or 4.1. You guys already have a little bit of, do you remember that seeing a graph that kind of looks like this? And I said, label where the reactants are, and you put them here, and you put the products towards the end. Okay, so as a reaction is taking place, first we start with reactants, and then we get products. Okay, this is what's happening in respiration. We're going to take glucose, C6, H12, O6. And when we're done, all we're going to have is these atoms all apart in pieces. We're going to have 6 CO2s, and we're going to have 6 H2Os. Okay. Now, do you remember you guys made some calculations for me? And you've seen some graphs on your test so far that have already introduced some of these ideas related to respiration. Do you remember what we call the amount of energy that we have to supply to start the breakdown of glucose or anything to start this reaction? Do you remember what that energy was called?
Activation.
Thank you. It's called activation energy. Okay. And do you remember that, like, sometimes we don't want to supply a lot of energy, but it sure would be nice if we didn't. If we have to supply energy, let's not have to supply so much. Do you remember how there was on one of your worksheets, you were supposed to do that? Because it said, show me how an enzyme affects activation energy. So now with an enzyme, and sometimes, they'll say, this is the activation energy with an enzyme. It's less. So now we don't have to provide as much energy to get this reaction to take place. And that would be beneficial. Okay. So and I just need to kind of understand, like, every single reaction it takes energy for this to happen, but if we use enzymes, then your body doesn't have to supply so much ATP. And it usually just has enough energy just because of the heat in your body to make these reactions take place. Okay. All right. So again, every step there's an enzyme, but I'm not going to show it to you. Not saying you won't ever see that, because this is a good demonstration of, this is glycolysis starting. There's actually 5 more steps after this, but this is glucose. Glucose is going to go into this enzyme. This enzyme is going to turn it into another molecule. That molecule, which is actually this one right here. It's going to turn into that molecule. Okay. And then this molecule is going to take that and turn it into another one. And then the enzyme number 3 is going to take that molecule and turn it into that one. Okay. And again, some professors make you know the names of all those enzymes, right? We won't do that in here. Okay. So next step in glycolysis. We're still in, by the way, this is called glycolysis. So let's indicate this is glycolysis. I'm just going to kind of put a box around it and label number 1. Oops, sorry. Starting to lag. I don't like that. If there's anything I can shut down. I don't think there is. Okay. So the next step, there's an enzyme that is going to take this molecule that we have here. I'm just closing out of stuff because I can see it's starting to lag a little bit. And it breaks glucose into 2 smaller molecules. And they look like this. I've got each of them have 3 carbon atoms. I just cut it right there in the middle. Sorry, just trying to close things out. We're going a little slow. Okay. And don't forget, they have a phosphate on them. So I haven't removed any of the phosphates. We've got them right there. Okay. Does that make sense? That's an easy step. Just took it and broke it into 2 3-carbon molecules. Okay. Now, the next thing that we're going to talk about is a big idea. Chemistry. You guys remember oil rig? Okay, so I'm so glad that Mr. Tuning is at our school, because when I first got here, I was teaching kids. I was like, oh, you guys know oil rig, right? And they're like, no. Well, the teacher that I used to teach at, the chemistry teacher, Miss Reese, she taught her kids oil rig. Well, Mr. Tuning was one of her students. So he learned oil rig, and now he teaches you guys, and he mentions oil rig. So now you guys kind of, if you had chemistry, this is going to help you out a little bit, okay? So up here, kind of at the top, I'm going to write oil rig. Oil rig. So oil rig is to help you remember what happens when we have oxidation and reduction of molecules, okay? So all oxidation is when a molecule gives up a proton and an electron. So oxidation is losing. That's what oil rig is supposed to help you remember. Oxidation, if you want to write it out, you can, is losing. Remember an H+.
You stop presenting.
Thank you.